wondered how a DNA profile is built? I mean, we see these things a lot in forensic shows, or we see it in paternity testing.
Andrew, you are not the father.
Well, we do need to find out who the baby daddy is, but no one ever really goes into the science of how you actually build a DNA profile. Today we're going to be looking at this technique called gel electrophoresis. It sounds fancy, but it's actually not that difficult. All it is taking a little bit of DNA and separating it through a gel using electricity. Now, the reason we're able to do this is because DNA has a really interesting property in that it is negatively charged. The sugar phosphate backbone of DNA gives it a negative charge. So the great thing is, if we chuck an electrical current through a gel, we are able to draw electricity through because it's attracted to a positive electrode. To help teach you today about gel electrophoresis and DNA profiling, we're going to be looking at a real-life forensic case. We're going to be looking at the sad but true story of Earl Washington. To set the scene, we need to take this back to the evening of June 4th, 1982, to the town of Culpeper, Virginia. That evening, 19-year-old housewife Rebecca Williams returned home from work to her apartment, which she shared with her 3 small children. She didn't lock the door behind her, and a strange man entered her apartment, attacked her, stabbed her repeatedly, dragged her to the bedroom, raped her, and stabbed her again before fleeing the scene. Williams was able to stagger outside and call for help from her neighbours, and as the police arrived, she was able to describe the man who attacked her. Williams described the man as a lone, black, bearded man, and she unfortunately did slip into a coma and die. Now, nothing was really happening with the investigation for 11 months until the arrest of Earl Washington. On May 21st, 1983, 22-year-old Earl Washington was arrested in Warrenton, Virginia on an unrelated case of burglary and malicious wounding. During 2 days of questioning by Virginia State Police and local authorities, Washington confessed the murder of Rebecca Williams as well as 3 other rapes. But was he guilty? Questioning and testimony of Earl Washington revealed that he did not know that Rebecca Williams was white. He did not know the address of the apartment where she was killed. He did not know that Rebecca Williams had been raped. He described Rebecca Williams as short when in fact she was 5'8", and he said that he had stabbed her 2 or 3 times when in actual fact she was stabbed 38 times. Earl Washington also stated in his testimony that he was alone in the apartment when he attacked Rebecca Williams, when it was known that her 3 small children were in the apartment at the time of the attack. And finally, Earl Washington could not identify Rebecca Williams' apartment without police assistance. So the question remains, why would he confess?
Did you kill that woman?
No, sir.
But you told the police that you did.
Yes, sir.
Why did you tell the police that you did it?
I don't know.
You don't know?
No, sir.
Did you understand then that you were being accused of a murder?
No, sir.
You didn't understand that?
No, sir.
When the police officer was asking you questions, what did you think?
Oh, I don't know.
Earl Washington was mentally handicapped with an IQ of 69. To give you context, the average IQ is around 100, with 68% of people scoring between 85 and 115. Now, to compensate for his disability, Earl Washington tended to defer to authority figures and agree with them no matter what they said. Earl Washington was found guilty and sentenced to death on January 20th, 1984. His confession was the only thing linking him to this crime. So, is there actually a better way to prove someone's guilty or their innocence in criminal cases such as this? Well, we're going to be looking at that today. We're going to be looking at how to build a DNA profile. The steps of DNA profiling are pretty straightforward. We start by isolating DNA from the crime scene and from our suspects. We're going to make lots and lots of copies of DNA using the process of polymerase chain reaction, or PCR. We looked at that in an earlier video. After that, we're going to analyze and compare amplified DNA from the crime scene with our suspects. And hopefully from there, we're able to identify who committed the crime. For our first step of DNA profiling, we need to isolate DNA samples. So we're going to be looking at collecting biological samples with viable DNA. So if we've got things like blood, we're looking for nucleated cells, such as white blood cells, because this will actually contain DNA. We can also collect samples of DNA from things like our hair roots. So the actual hair itself is dead keratin, but if you get a root cell, we can actually get a nucleus that we can, extract DNA from. We can also collect DNA samples from some skin scrapings, semen, as well as saliva. So any biological samples where we can isolate a nucleus and get DNA is fantastic. Now, if we've only got a small amount of DNA, we're going to need to amplify that so we have plenty to work with and test. So that process relies on PCR, or polymerase chain reaction. I'm not going to go through the steps of PCR today, but if you wish to learn about that more, please watch the earlier video on PCR and how that works, when we can actually take a small sample and amplify it and make millions and millions of copies of DNA. After the PCR process, and we've got lots of DNA to work with, what we're going to be looking at is actually comparing that DNA using a process called gel electrophoresis. Now, gel electrophoresis is basically this gel called agarose. Agarose has a fine mesh matrix in the inside. So what's going to happen is long strands of DNA are going to get pushed through, and depending on how big they are, they travel at different rates. So a small fragment of DNA is able to travel through the gel really, really quickly compared to a large fragment of DNA, which moves a little bit more slowly. Gel electrophoresis uses wells in our agarose gel. So these are small divots in this gel that we actually are going to put our DNA samples in. After that, we're going to add a buffer solution because we need that for a current to actually run. So our buffer solutions could be things like sodium bicarbonate that are just added into a chamber. We then apply an electrical current. So the electrical current is drawing that negative DNA through the gel towards our positive electrode, because positives attract negatives, and our DNA is going to move towards that side of the gel. We're going to run the current through until we have distinct separation of our DNA fragments, and they'll form separate bands that we can then analyze and look at and see, well, what are the different size fragments of DNA that we're working with. The thing with the gel electrophoresis though is that it's just giving us relative sizes of DNA. I can work out that a fragment on the bottom of the gel has to be smaller than a fragment at the top of the gel, because that's how this process works. So what we actually can add to determine an approximate size of our DNA fragments is adding this thing called a DNA ladder. DNA standard ladders act like a molecular ruler. So they're different fragments of DNA of known size. I know exactly which size the different fragments are inside of this DNA standard. So as I run it through the gel at the same time as my tested DNA samples, I can use that as a point of comparison. So for example, this smallest fragment of my DNA ladder is 40 base pairs in size. This other fragment of my tested unknown DNA sample matches up along this line, so therefore it must also be 40 base pairs in size. So let's have a go at actually approximating the size of unknown DNA fragments using a DNA standard ladder. Now in this case, our gel has a little column called L. That's the ladder, and that has different DNA fragments of size between 100 base pairs to 40 base pairs. Lanes 1, 2, and 3 have DNA samples of unknown sizes. So if I'm looking at this particular sample right here in lane 2, this particular line, can you work out what the approximate size of the DNA molecule would be? Is it 62 base pairs, 68 base pairs, 73 base pairs, or 81 base pairs? This feels very Dora the Explorer, where I'm asking you a question and then I answer my own question 5 seconds later. Except I guess Dora doesn't go into this much biology, and I don't have a cousin named Diego. That was a weird tangent. Anyway, our answer is 73 base pairs, because if you can have a look at our DNA fragment, it's somewhere between 70 and 80 base pairs when you compare it to our DNA standard. And as 73 is the only option in that range, you are using some logic and working out, well, our DNA fragment must be 73 base pairs. Great job, hopefully. let's go back to the case of Earl Washington. Now, a year and a half after his conviction, Earl Washington is transferred to the execution site at Virginia State Penitentiary, and it's here that he hears that electric chairs are being tested. This is actually the picture of the electric chair used at Virginia State Penitentiary, and it was known as Old Sparky. That's pleasant. While Earl is on death row at Virginia State Penitentiary, another inmate learns about his case and tells his lawyers about it, and these lawyers take on his case pro bono. Luckily, Earl Washington was awarded a stay of execution 9 days before his scheduled execution. For years after his stay of execution was awarded, Earl Washington's lawyers appealed the courts trying to prove his innocence. However, they did not succeed. On October 25th of 1993, semen found at the crime scene was tested for DNA, and it was found that the DNA did not match Earl. However, Virginia state law states that new evidence can't be presented in a trial that's already been concluded, so they couldn't actually exonerate Earl from this evidence alone. What they did do in 1994 was have the governor declare that Earl was no longer on death row, and instead he was in prison for life. That criminal justice system is pretty broken. Let's fast forward almost 16 years to January 2000. Earl's lawyers request that an additional DNA test called STR analysis be performed on the DNA found at the crime scene. So what is an STR and how do we analyze it? STR stands for short tandem repeats, and these are stretches of DNA in known positions in your genome that will vary in how many times a particular sequence repeats. So for example, in this STR, the sequence repeating is AGAT. In one person, that might only repeat 3 times. In someone else, that might repeat 10 times. The thing about STRs is that they are highly variable between people who are unrelated, and we can use the properties of STRs where we know where they are in the genome and we know that they're highly variable between people, and use this to create DNA profiles. So we're going to use the same 3 steps of DNA profiling. We're going to isolate DNA from the crime scene, we're going to amplify DNA, but in this case, we're going to amplify STR regions, and then we're going to actually compare profiles using gel electrophoresis and STR regions. Because STRs vary in the number of repeats they have, the size of your DNA fragment is going to vary as well. So if someone has a really large fragment in that STR region, they have more repeats of the sequence compared to someone who only has a small fragment. We can use a gel electrophoresis to actually compare these 2 individuals and match it with the DNA found at the crime scene. Because STRs are inherited, you have 2 different variations that you've inherited from your parents at each STR region. We call these alleles. So the chances of you matching every single STR region with someone else is incredibly rare. Unless of course you're an identical twin, in which case I hope you have an alibi. Now you might have seen that in criminal investigation shows, they refer to this DNA database called CODIS. This is what they use in the US, and it's using all 13 STR regions as a point of comparison. The chances of someone matching all 13 STR regions with you is over 1 in a billion. In the case of Earl Washington, on October 2nd, 2000, Governor James Wilmore released the results of STR analysis performed on the DNA found at the crime scene, and it was found that it did not match Earl Washington. He was granted a full and absolute pardon and was released on February 12, 2001. He'd spent 17 years in prison for a crime that he did not commit, and he was awarded a $2.25 million settlement. He currently lives in Virginia Beach with his wife and kids. Now, the murder of Rebecca Williams did not go unsolved. In 2007, Kenneth Tinsley, who was an inmate already serving a life sentence, had his DNA tested against the DNA found at the crime scene, and it was a match. He pleaded guilty to the rape and murder of Rebecca Williams and remains in jail until this day. I hope you learned a little bit more about gel electrophoresis and how we can use STR analysis to create a DNA profile. The field of forensic science is always improving as we learn more about DNA, so don't commit crimes. They'll find you.